Ladies and gentlemen, please welcome the 1511 band.
Welcome to the final countdown. We won't talk about how long that took you to do. on a quite a classic keyboard, as you can see. And yeah, Tom's on microphones. Fantastic. Welcome to the final lecture. It is Tommy, Tammy, and me in the house. We've even dimmed the lights, but no one can see that. So maybe we'll turn the lights back on to start. Very big lights now. All right, here we go. And now we're going into the lecture, unfortunately. And, okay, here we go. Oh, golden buzzer. Yes, we go. We should have confetti. We're into the next round.
Did someone turn their chair for us?
Oh, wait, I forgot to remove the camera. Just, can everyone please appreciate the keyboard? That is just amazing. Thank you, Tom. All right, give us a second to set up. Now my face is just huge as well. And all right. Hi, everyone.
That'll do.
They'll sort us out.
Yeah.
Can I have my mouse back?
Oh, yeah. Sorry.
Thank you. All right, welcome everyone. It is the last lecture. I cannot believe this wonderful turnout considering the assignment is due in a few hours and it is week 10. Thank you for coming through and coming into this last lecture of 1511. I can't believe it. I can't believe it's been 10 weeks. The keyboard just meowed at me. I'm sorry. It's lost Tammy a little bit. She's loving the meows. So yeah, okay. Someone said, "Oh, a song manager library for assignment 2 next term." Well, funny you say that. That has been an assignment in the past. So yeah, excellent. How's everyone feeling? Friday, last day of term. I hope everyone is feeling amazing. How are we feeling? How are we feeling in the chat? The delay is epic. It's all almost done. We're all almost done. Yay! That's maths, isn't it? 1131. It's maths. You can last. The final lecture, this is it. Finished assignment 2. But only for the maths exam, okay. When is the maths exam? Is it before the comp, after the comp? Question 6 of the prac exam. Have you been stacking? It's a stack. Before. Oh, it's the Friday. It's the first exam, the maths one. Oh, okay. What a way to start. What a way to begin the exam period. Oh, I remember those exams. Oh, everyone's ahead. Today's lecture code already. I'm still on slide 2. Okay, here we go. Slide 2. So, on Tuesday, which feels like ages and ages and ages away. In fact, it was only a few days ago, but this week has just stretched, I think. We talked about the exam. So if anyone has any questions, pop them in the chat. We did a quick revision of pointers. We did an example question 1, which was an array of structs, which was super exciting. And today we're going to continue. Oh, look, I'm killing something here. What is this? Let's kill that. There we go. So today we're doing linked lists. Yay, more linked lists. So some example problems for revision. Live lecture code. Tommy or Tammy was ahead of the game and they pasted already the lecture code in here. All right, I'm going to bother you one more time for my experience surveys. If anyone hasn't done them, please do so. We use the course feedback to improve the course. It's really important to us to be able to constantly be improving the course. We've got a lot of ideas and we want to be able to see what ideas that we've put into play this time have worked and what hasn't worked so well. So it's really nice to be able to get your feedback. It's a huge course. It's such a great testing base. When we make mistakes with our auto tests and stuff, and everyone is like, "That's a mistake." So it's nice to see, and it's the same for feedback as well. It's nice to get that feedback. All right, revision classes on Hail will be released later tonight after the assignment is due. So come along. In week 11, we're going to be running our revision classes. So if you would like to revise, come along. There's going to be revision problems. You're going to be in a class and support of our lovely tutors would be, moving around the class. I heard that the CSE SOC event had quite a good turnout. 60 or 70 people went. I hope you found it to be useful. And there were some good problems in there actually. So hopefully you found that to be useful if you did go to that. Our 1511 ones are running. There's one online on Tuesday, the 26th of April, 3 to 5 p.m. And then face-to-face ones are in Brass Lab. And it is on Wednesday and Thursday. Wednesday is 11 to 1 and Thursday is 3 to 5. So hopefully if you want to, you can make one of those and it kind of stops you procrastinating a lot as well. Okay, linked lists. Let's talk about linked lists again. I had someone tell me yesterday that they actually like linked lists more than arrays. Let's have a poll. Who likes arrays more than linked lists? Tammy's on. Sorry, Tammy. Tammy had just gotten up from the chair and I'm like, let's do a poll. I'm going to wait for the distinct moment you're not around to do it, and then I'm going to ask you to do it. I want to know. I want to know what the stats are. Linked lists or arrays? Who loves which one? Oh, that's not what I meant to do. Oh, Tammy can't. Tammy would choose linked lists, right? Yeah. Tommy? Yeah, Tommy would also choose linked lists. I feel the same. It's weird. They're just neat. They don't do weird things. Well, that's a lie. They can do some weird things, but yeah, linked lists. Lots of people do like linked lists. Look at that. Overarching support for linked lists. That's what I like to see. I don't know, once you draw them, they really the diagrams are just amazing. So linked lists, so we can only access things sequentially by traversing the whole list. We can't just index to whichever element of a linked list we know we want. We don't really know how big a linked list is until we travel through it and check how many things there are in the linked list. So that's a downside of a linked list, the fact that you have to go through every single element to find something. We can add nodes in as needed, dynamic memory allocation by using malloc size off struct node or whatever it is. We can delete nodes as needed by using free. And look, it's good. I just carry on my lack of bracket consistency all the way through to even writing. I just can't seem to close brackets. HTML was a terrible, terrible stage of my life for me. I'm not very good at closing brackets. Yeah, that's true. Yeah, I feel like who's come to this lecture probably has gotten quite far on the assignment or finished it. So probably likes linked lists a lot. So a biased poll, but nonetheless, I'll take it. And we can check for memory leaks. Has everything been freed? By using the DCC leak check command, then it will tell us what's leaking and perhaps where we've forgotten to free. A lot of the time, it's the fact that if you have a root structure and you have, stuff coming out of the root structure, you forgot to free the final root structure. You've forgotten to free the whole thing. That's usually the mistake that people make. They'll free up every node, but they'll forget to free up that top node, which stores your head. Okay. So just a reminder of what a linked list looks like in case you haven't seen one for about 2 minutes after you finished your assignment. We have a head pointer. It is not a node, but it holds the address of the first node, unless you have a node in here that holds the head of the next struct node. So I guess you can have different types depending what the context is. Then we have our nodes that have some data in them and the address of the next node, and then the next one and the next one until you finish up. Oh, look, without fail. Oh, no. No, I haven't. I did fix these addresses. Okay, I thought I typoed the addresses, but I haven't. And then we know that we've gotten the end of the list when we hit the null, and that's when we know it's all done. Okay, so Okay, some special boundary conditions that I want you to consider when you manipulate lists. So in the exam, when you get into the exam, you have a linked list question and you have to do stuff. Think about these 5 cases and make sure that you've taken care of them, okay, depending what the context is of the question. What happens if it's an empty list? What happens if it's a list with one element? Does your code work for that? What happens if something's happening at the beginning of the list? What happens if something's happening at the end of the list? And what happens if something will not occur? So the item is not in the list. So for example, you want to insert after a number that is not there, or you want to delete a number that's not there, so what happens then? Will your code still work as well? Okay, time to get into some practice problems. Let's do it. And we're going to be just doing a lot of linked lists. Okay, problem number 1. And this might be, okay, so I said it's a 1 dot, but really it's probably a mixture between a 1 and a 2 dot, just because of the amount of stuff you have to do, not because of the potential difficulty level, if that makes sense. Okay, find the range, which is a difference between the largest and the smallest item of a linked list. So let's say we've got a linked list of numbers. We want to find the largest number in that linked list, and we want to find the smallest number in that linked list, and then we want to subtract them, and we've got the range. Okay, let's do it. Let's return the keyboard. Oh, yeah, my table is very high. I was wondering why it's feeling a bit awkward to type. Okay, here we go. I am it's just when Tom stood next to me and Tammy, it was a bit depressing, really. Okay. Here we go. Ah, very nice. All right, so what I have in the lecture code is I've basically copied the file over from week 8 that we did for linked lists, and I've tidied it up so it doesn't have all the rubbish from before in it, but it has like a lot of functions so that I don't have to write them again, because even in your exam, we will have like a few functions in your linked list one that will allow you to quickly test whether or not what you've done is correct. So, we'll provide you with a printing function so you can check if it's working or not, and stuff like that. So this is kind of like the same sort of idea is what I've done as well. I've kept our create node. I've kept our printer function and inserting function so we can build up a linked list, and I've just left the delete node in there because why not? And now we'll just kind of do our function. Let's go down. These are all the functions that we've already written in week 8 and week 7. And so now we're up to revision problem 1. Okay, function to find the range of the list. Okay, how do we think we're going to solve it? So I've described to you that we want to find the biggest number in the list, find the smallest number in the list, and then, oh, didn't want it to do that. Subtract those numbers. Okay, so what do we think we will be returning, and what do you think will be the input of our function? Yep, Excellent. So we will definitely start by traversing the list. But what do you think we will be? Do you think will be our output and input? Well, what do we reckon? What will this function output if it wants the range of the list? What will it output? Thank you. Output would be an integer. Yep, so the range is just an integer. Excellent. And input will be the head. Excellent, well done. The input will be the head of the list where we're finding the range. Excellent, okay. Let's do it, okay. So we're going to output an int, and we're going to be, let's call it find range, because I don't know, that seems like a good name, but I'm not very good at naming things, as you've noticed. So, okay, and we're giving it a head of the list. So struct node head. Okay, and now what will I do? Okay, so remember we had those classic cases to consider. Okay, so what happens, and I always think about this one before I start. What happens if the list is empty? Okay, because I can't really traverse it. If I start traversing an empty list, I'm going to not go very far. So let's take care of what happens if the list is empty. How will I check if the list is empty? What do we reckon? What's going to be equal to what if the list is empty? So range would be 0 if it's empty, yeah? And we can check if that list is empty if head is equal to null. Excellent. So if head is equal to null, then exactly as Sophia said, we will return 0. Very good. Excellent. Okay, good. And so now okay, I'm going to do it with the help of some helper functions. Okay. Someone said, so would we return 0 or return null? We would return 0 because 0 is an int, and we've said that the output of our function is an int. If we're returning null, we're returning a pointer. Okay, so if we were returning the head of the list, then we would return null, like if that was the output of the function. But because the output of our function is an int, we're returning 0 in this case. So does that return 0 or end the program? So it returns 0 to the main where it was called from. Okay, that's what it does. And your 0, when you write return 0 at the end of the main, that's just returning 0 to say the whole program finished running in the main. So the main finished running without any problems. Okay, excellent. Otherwise, let's find the range. Okay, so I'm going to have an int smallest, and let's just say I'm going to have a function called find smallest. I'm just going to go crazy with functions. And I'm going to give it the head of the list. And then I'm going to have a largest. And I'm going to have another helper function, and I'm going to call it find largest. I'm going to give it the head of the list. And then what am I going to return? I'm going to return the largest minus the smallest, which is what the range is. Okay, so now let's implement those little helper functions. Okay. Helper function to find smallest number in the linked list. Okay. What is going to be the input and output of this one? What do you think will be, oh my gosh, what do you think will be the input and output of a function to find the smallest number in the linked list? So I kind of gave this one away because I'm storing it, the result of this, I'm storing it inside an int smallest. So what does that mean? What does that mean I'm giving back? Yep. Input head and output an int for the smallest. Excellent. So I'm going to give it the head of the list, and I'm going to output an int, which is going to be the smallest number. Excellent. Okay. So I'm outputting an int, so it's int, and I'm going to call it find smallest, and I'm giving it the head, so struct node head. Very good. Okay. Now, how do we think we're going to traverse this list to get the smallest number out of it? What do we reckon? What do we reckon we're going to do? Yep, compare as we go through the list, make the first element the smallest. Fantastic, well done. Okay, so what I'm going to do is I'm going to say, first of all, I'm going to say a struct node current is equal to head so that I'm ready to traverse the list. And then you're right, I'm going to have a smallest number and I'm going to make it the first thing that's in the list, okay? So what I've done is I've said, let's say I have a list of numbers and the list of numbers looks something like this. So let's say 1, 2, 3. What I've said is this is going to be my smallest, and then I'm going to compare it to the next one. And if this is smaller, then I'm going to make that the smallest. And I'm going to go to the next one, and if this is smaller, then I'm going to make that the smallest one. Okay? Yep. Okay. So then we have our smallest, and now let's traverse the list. Oh, I forgot to switch back. Okay. So whilst my current is not going to be equal to null, so in this case I'm going to go all the way to the end of the list, okay, because I want to be able to visit every single element to check it, okay? Okay. We can absolutely, instead of using two helper functions, find both the lowest and the greatest in a single loop, but why not practice using functions as well whilst we're there? Okay, so then if the next one is going to be greater than the smallest one, so if current data is going to be, no, not less than smallest, which was my first thing that I set to, then I'm going to make a new smallest. So then I'm going to make the smallest equal to the current data. Yep. And then I'm going to, oh, I forgot to, thought I'd create a quick infinite loop whilst I was there. Okay, and then current next. And at the end, when we finish, all we have to do is return whatever the smallest is in there. Okay, does that look all right? How is everyone feeling about the smallest, finding the smallest? Because finding the largest, which is going to be much of the same thing. Yeah? Okay, let's call it find largest. And again, I don't know if people have lost me or if people are all, there's no questions. How are we feeling? Any questions or have you lost? And so this time you're going to check if the current one is greater than the largest, and then you're going to make it the largest. And we can go through the code line by line as well, okay? So please let me know if you would like for me to do that. Oh, this is easy. Okay, music to my ears. All right, that should do it. Should we try it out? Let's try it out. What's our list? 531. Maybe something else inserted in there. Okay, and then I deleted something as well. No, I'm just going to get rid of this. I'm going to get rid of this. And prototype, thank you very much, whoever's there. Yes, so many prototypes that I have not done. Yes, you're right. Okay, I've got int find range. And I've got int. It wasn't called smallest, was it? No, find smallest. Okay. Excellent. Okay. So we're going to print out the list. Oh yes, well, you're right. We're going to print out something. You're right. Okay, so I'm going to go I'm going to do a printf here. And I'm going to do the range of the list is %d. And then I'm going to call my function find range, and I'm going to give it the head pointer, which is the head of the list. Now let me consider my, yep, that's correct, brackets. Okay. Okay, let's save it. Let's see if it runs. Let's not torture myself. There we go. Okay, the range of the list is 9. I wonder why I forgot to print out the list. Let me print out the list so we can see if it's actually 9 or if it's or if I'm just fibbing you. I hope I'm not fibbing you. Okay, let's run it. Okay, so the range, it is 9 because it's 10, take away 1, and it's equal to 9. Okay, how's everyone? Is that one easy? That's a one dot. Tammy, are you doing a poll already? There's a poll there. Yeah, oh, amazing. Yeah, let's do another one. Let's do another one. Question 1, okay? You can't see most of the term. Oh my God, you can't. You're right. It's because my screen shifted in all the excitement. There we go. Now you can see it. Thank you so much. Yeah. Thank you for letting me know. I don't know how that happened. Yeah. All right, quick poll. How are we going on the one? And then we will move on to the next question. Gosh, we're gonna have time to do a whole exam today. Not quite. I'm not doing a question 5, 6, 7, or 8. Okay, great. So far, so good. Only 24 people are voted. How many people are in the stream?
69.
Okay. We'll go with that. Is there any way you can access more practice exam questions? Have you looked at the revision on the bottom of the screen? Hang on, let me show you. Hold up. Let me show you where to find it. Oh, hang on. Just wait for it. I'm coming. I'm just doing it on the other side. Oh, struggle town. So, thank you, Tom. And then it's... Okay, down here, you can see we've got revision down the bottom of the website, and each one has a whole bunch of questions in here that you can use as revision exercises. There's a ton of questions, and these are going to be some of the questions that we're going to be going through as well in the revision classes. So if you're stuck on any of them, you can come and, have a look. There is some short videos that we have as well if you wanted to have a look, and renew your understanding of things. So each one of them is a short video. Some of them are a little bit old. We are redoing new ones, so don't worry. Yeah, and it will allow you to really go through each one of these and really practice each of the things. And it gives a lot of questions, and the questions are structured similarly to kind of how our exam questions are structured as well. But it will give you a chance to have a lot of, a bit more practice as well. And some of them obviously have 1 or 2 things because their topics are mostly... like arrays and linked lists are the 2 huge ones, okay? Because obviously those are the things that we want you to do really well in, because that's the 2 hurdles. And then this is just really, if you wanted to learn more about, stacks, you can do a few things here, and you can kind of have a look at this exercise if you wanted to. But remember, stacks is only a very, 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 very small part of the exam. Yeah. Okay, so that will allow you to have a lot more practice questions, because you're right. And if you, did anyone here go to the CSC SOC thing? Anyone here go to that? Some of the questions were okay as well. Will the exam be supervised? It won't be supervised in that I'm not going to be watching you, because I think that's just ethically, I don't like it. So no one's going to be watching you as you do the exam. But we are there in the background in case you have any problems. We are available throughout the whole of the exam, and you send us an email to cs1511.exam. Is it .exam? Yeah, .exam. And which the email will be in the message that comes to you, okay? And it will come to you from that email address. So don't worry, you don't have to remember it. And, we will sort it out. So if something's not running, if you think an auto test is wrong, if you think there is a typo, if a question doesn't make sense and you want to just clarify it, you just send an email to us and we will reply straight away. Okay. So don't sit on it and think, I don't know what to do now. Just send us an email. Okay. And we'll sort it out straight away. There's quite a few of us. Yeah, so I think the questions from that event, also the CCSOC the CCSOC event are available as well. So I think, so you're right, Sophia. So I looked at the questions and a few of them were quite hard questions. They were not good for the beginning questions. And they were structured kind of differently to how we structure 1511 material. So definitely... definitely use our revision questions as well. They're great because they're structured the way we structure the exam as well. Go through any of the lab exercises, any of the problem set exercises that you couldn't do. Try them again. There's solutions there as well to help you, because that will also help you. So that's definitely that. And how long is the exam? The exam is 6 hours. And you can work for as long or as little of those 6 hours as you want, really. In case you have any technical issues, that's why it's 6 hours. It wouldn't be 6 hours if we were invigilating it. Okay, I hope that helps. Okay, I'm going to close this now. There is some starter code. Absolutely, there's starter code in the exam. And the linked list question in the exam will have... you won't have to make the list, if that makes sense. You'll just have to do something to the list. And, you won't have to do the function to print out the list. It'll just be there on the bottom kind of thing working for you, so you can see what the output is of your command if it's relevant, whether your function works or not. So kind of like that question we did on Tuesday for array of structs, which had a few things in it, that was, we had everything there for you. All you had to do was write the function that does something. So that's kind of like that feel. Until you get to like question 6, 7, 8, we don't do much for you. Question 8 this time does have quite a bit of starter code to do all the really, really more complex bits, and leaves you to do the less complex but still complex bits. Then they're definitely complex. It's a cool question. Okay, so hopefully, hopefully you'll enjoy, do you enjoy exams? I don't know, but hopefully you'll enjoy the exam. Sometimes, sometimes you do get an exam and you're like, that was all right. So I want everyone to strive to answer the first 4 questions if you can, and the short answer questions. That will be ideal. That's 60% of the exam. So that's pretty good. All right, excellent. Let's continue then. Let's do the second part. I don't know, what did I have for second question? What did I have for the second one? Okay, insert a specified number into the middle of a linked list. Assume that there is always going to be an even number of numbers in the list before insertion. Just made that question easier so that I didn't have to do some magic. Okay, so what that means is if I have a linked list, and in my linked list I have, the numbers. Let me write it down. So let me go down. Here we go. So let's say, for example, I have a linked list and it looks something like this. Okay, if I want to insert, if I say this insert in the middle, and I ask it to insert the number, the number 10, okay, then it will go and find the middle of the list. So the middle of the list is going to be over here. smack bang in the middle, and I'm going to insert that number 10 in here. So this is what this one would do. So what do we think will be the output and the input of this type of function that will take a value, it will, do a node, and then it will insert it in? What do we think that's going to be? Yeah, well done. So I'd insert after 3. Oh, was this in the week 9 problem set? Was it? I checked and I couldn't find it. Hang on, Tom's going to check. If it is, we're going to move on to the next one. It might have been. I've been very excited with inserting in the middle, so I could have been like, you have to use it for the lab. Aha, it was delete in the middle. Yeah, okay, it was delete in the middle. Yeah. So let's do insert in the middle. But I hope you're starting to get the feel of like a lot of these things are very similar. Like what you have to do is you're constantly kind of doing a very similar thing. Once you get the gist of how you're like traversing it and how you're finding something, the hard part is inserting something or deleting something, because you have to consider a whole bunch of cases. And that's why anything with insert or delete is sort of a 2-dot question in difficulty. Okay, so what are we saying? I can actually make it void. I can make it void because I'm inserting in the middle. So the head of the list is not going to change, or will it? What happens in the case, and you're right for that, but what happens if I have a list, well, I can't because I told you it's always going to have an even number. What happens if it's an empty list? That's still an even number. 0 is an empty number, is an even number. So what happens if it's an even number? And I will say, so I'm giving it nothing in the list, and then I'm going to say insert middle 5, okay? Then I really wanted to return that 5, which means the head of the list is going to change, okay? Yeah, so that means that we will have to return the head. Yeah. Okay. So that means the output is going to be the head, and what's going to be the input? Yeah, it's unfortunate. The timing of this lecture is very unfortunate with the assignment. So lots of people, I think, are finishing the assignment madly. And I really feel for them. And I wish I could have made this deadline later, but unfortunately I can't. The university policy, I took it as late as I could. Yep, value and head. Excellent. Accepted your defeat. Getting to the end of stage 3 is fantastic. What are you talking about? That is incredible. Well done. What an absolute, effort. So the input is going to be the value that I want to insert and the head of the list. Excellent. Fantastic. Okay, let's do it. So we're going to... Sorry, I just thought I saw a cockroach, but I didn't. It's not a cockroach. It's my shadow in the Apple logo. And it just moved and it was black and out of the corner of my eye. I was like, this room is disgusting and I haven't even been here for more than... It's not me, I swear. Okay, struct node. What are we going to call it? Insert middle. I guess I've already given it a name. Model, middle. Okay. And we're giving it an int value. And we're giving it a struct node head. Okay, excellent. Let's do it. Sophia, you're getting people to exit the lecture to try out stage 4. It's all right. If you do go, I understand. I won't be offended. How much are the edge cases worth? In which stage? Or do you mean for this question? As the stages go up, the edge cases start to be more value. I am loving the level of encouragement in the chat. I really appreciate this. I really like the supporting each other is amazing. Well done. Yeah. Yeah, yeah. Like if you pass all the auto tests and fail at the edge cases, what are we getting? Sorry, I meant for the whole of assignment 2. Okay, the earlier stages, you will do better because the auto tests cover a lot of the edge cases. The later stages, we are letting you figure out a lot of them because the tests are like the requirements, the equivalents of them, okay? So if you fail the edge cases, you will still get, at least half the marks. It's not like edge cases is everything. But if you think about 5 cases that I've talked about, you will cover all the edge cases. Yeah, 3.3 and yeah, it is, yeah. Yeah, and that's why exactly. Stage 4 only has 2 auto tests because, you're on your own. Living the dream. But remember, the majority of the marks are also in stage 1, stage 2, and then if you finish stage 3, you've got like, I can't remember the exact, but it's like, it's like 85, is it? Yeah, you can get 85% for the assignment, which is amazing, I'm so amazed. Anyway, everyone's doing, just the fact that there's 68 people in here, I'm amazed at that. Okay, let's sorry, I'm very easily distracted, obviously. It's Friday afternoon. I'm ready for a good chat. If you think about the 5 cases mentioned at the beginning of the lecture and apply them to the context of assignment 2, you'll be able to think of all the things that can potentially go wrong, okay? How do you find the edge cases? Think of the 5 things that I talked about at the beginning of the list. Something happening at the beginning of the list, something happening at the end of the list. Think of something happening if that item is not in the list. Think of something that's happening if it's an empty list. And think of something that's happening. I forgot what I've already said. There's like, yeah. Okay. Let's find the middle. Should we insert in the middle? How should we find the middle of our, everyone's so busy talking about the assignment. I'm getting sidetracked about the assignment as well. Okay, if we're inserting in the middle, how do we find the middle of the list? What do we think? Is everyone switching to assignment chat? Okay. I know what facts means now. Someone says facts, but someone wrote it on the forum and I didn't realize. I was like, how would you know what a fax machine is? You're too young. The person was not talking about a fax machine. No one even knows what I'm talking about. Don't worry about it. Yeah. So Jonathan, loop through, count the number of nodes, and then divide it by 2. I love it. Perhaps use a count is equal to 0. That is a great variable. I like it. Tom now understands what I'm talking about. I'm not going insane. However, the air conditioning has switched off in this room, so I am slightly going mad. Okay. Struct. Did you just break something? Strut. God. No, I'm becoming hysterical. I'm sorry. Struct node current is equal to head. Okay, so that we can traverse the list. Wait, do you know what a fax machine is? Yeah, okay. Yeah, everyone, okay. People do know, okay. But have you ever used one? No. This is what I mean. I feel old because I did used to use one for work. Imagine that. Do you know how cool it is to like send a message and someone gets it across the world 10 minutes later? equal 4. I need to stop. Okay, but let's back to the question. Insert in the middle. Struct node current is equal to head. Excellent. Now we're ready to traverse this list. Okay, but what do we need to do? We need to create this node that we're going to insert into the middle of the linked list. So I'm going to create a new node. Okay, I'm going to say a new node is equal to, and remember, I have this wonderful function create node that I already have. So that's neat. I'm going to use that function. I've forgotten which way it goes though, so I'm just going to check create node. It wants the data and the struct node address. Okay. So I'm going to create the node with value and I'm going to give it a null. So this will this will create the node with the value so that we're ready to insert it into our list. Okay. So now we have a node and someone has suggested a fantastic variable int count is equal to 0. I couldn't agree more. Great variable name. Okay. So now let's start to think about what we need to do. What should we check? No, next comment. Okay. I forgot what I was. Any edge cases that people can think of? I love to start with the obvious one before I start doing anything. What's the very first thing I would like to think of? And you have to just read my mind now. What's the first thing I like to think of when I get given a list? What should be the first thing I check before I start traversing it? What do we reckon should be the first thing that I check before I start traversing the list? Yep, I'm going to check if the list is empty. I'm going to check if the head is equal to null. Because if the head is equal to null, that means my list is empty and I can't really do much. Well, I wouldn't want to traverse an empty list. Okay, so if my list is empty, okay, then what will I do? Okay, and we've talked about this case here. If my list is empty, I'm just going to insert this node into the list, okay? So if the head of the list is equal to null, then I'm really just going to, what am I going to do if I'm going to insert my new node in? What do we reckon? Ice cream, I mean, anytime really. But what do we reckon we're going to do? I'm just going to... Yeah, well done. Good. The new node is going to be my head off the list. Will it? If I do this, new node is equal to head. Okay, what's that going to do? And head is equal to null right now. What's that going to do? Yes, well done. Okay, someone's got it. Yeah. So remember, so my new node next is going to be the head because the head is equal to null. So what I've done is said new node and I'm going to return the new node because that's going to be the address of the head. Yeah, so wrong way round because otherwise you're going to make it equal to null. Okay, excellent. So now I'm going to traverse my list and count up the number of things I have in the list. That means I have to go to every single element in this list. So I'm going to go while current is not equal to null because I want to take every single element of the list and go all the way to the end. So I'm going to increase my count each time and then I'm going to keep moving to the end. Whoop. Here we go. Okay. So when I come out of here, I'm going to be at the end of the list and I'm going to know how many things there are. Okay, I'm going to know how many things there are in my list. So now I really am going to do, I'm going to see halfway is going to be count divided by 2. Okay, excellent. Now, what should I do now? What do we think is going to be my next series of steps? What do we reckon? I did try to just sing that. Yep. Yep, find the node before the middle one. I love it. Well done. And I'm going to call that node insert at. Maybe it was, so I'm just going to count up the nodes to see which node I'm going to insert at. Or I don't even have to do that, really. Do I? There's a number of ways to do it. This is what's coming to my head right now. I'm kind of looking at what I wrote before, but I'm also kind of free coding because other screens. Yep. Okay. So let's find the one we're going to insert after. So I'm going to create this pointer. I'm going to count the list because, okay, so I'm going to traverse the list again and I'm going to stop at the place where I'm going to insert after. Okay, I'm going to traverse it middle amount of times. Now, I can't use current anymore because current has gone to the end of the list. I could reset it again if I wanted to, but instead I'm going to create this new pointer and I'm going to set it again to the beginning. So now I want to get that pointer to the middle element of the linked list. Okay, so whilst insert at is less than, got it, mid, and I want to stop at the one beforehand, so mid minus 1. I really should draw it out. This is terrible. I really should draw it out. We're going to draw it out after this. Okay, because I think I've made a mistake, but we're just going with it. We're just going. Okay, I'm going to keep moving this one across, so I'm going to give it the current next treatment. And I'm going to increase this insert at a few times. Well, however many times I need to. Yeah. Okay. Yeah. That means when I come out, I'm at the node that is before, I'm at the node that's before the point of insertion. So that means I'm ready to insert now. So that means my new node next is going to be equal to insert after. I should really, no, I should draw it. I'm sorry. I'm going to write the code and then I'm going to draw it because I've drawn it in my head, but no one else can see what's inside my head, which is a shame. Actually, no, you don't want to see what's inside my head. It would just be madness. And then that's going to go to the new node. And then just to finish off nicely, return the head. Where's that bracket? Okay. Okay. All right. Something like that. It might or might not work. I'm not sure. I need to draw it out to just double check that that's correct. And let's have a look. Well, I might just try it out and then we can take a little break and then we'll draw it out. Oh, classic. Where else did I make a mistake? Nowhere else. Oh, I forgot to actually use this function. Okay, let's actually use this function. Okay, let's do insert middle, and we need a new head here. So struct node new head is equal to insert middle value 13 head pointer. Let's see if it works, and then printer new head. Okay, let's see if it works, and then if it does, then we'll draw it out. Oh, what have I done now? Oh, I forgot to do a prototype. Sometimes I just wonder. Wait for it, wait for it. Just without fail every time, right? How many times have you reminded me of a prototype? There we go. Okay, and yay, it did it. Amazing. But we do need to draw it out because I feel I've lost everyone. Just to, before we take a break, Tammy, could you do a poll? Who's with me? Who's lost me? Who's anywhere? Who's just like, when is this going to be over? And then we'll take a little break here.
What if we just said?
Ah!
What if we just?
There we go. Yeah, I just couldn't get that. That camera really hates me, so I just swapped to a different camera. We're back, and I was super blurry. Yeah, how many is in the lecture now? Like 40 something people.
55.
Sophia, I'm going to blame you because you said 4.1 and 4.2 is not so bad. Everyone's rushed off to quickly do their stages before their assignment's due. The other Tom has just come into the picture as well. It's a bit of a party in here. He's suggesting it's like last day of school. We put on a video now and just watch a movie instead of doing questions. And someone suggested, life advice. We just kind of have a bit of a chat. But there you go. Imagine a full course of HDs. I'd be so happy. I don't know if everyone else would be as happy. It would be amazing. But just, what would be so good about it? It's not the HDs, but like the confidence that people would walk away from the course with. I would really like that so that you can go into your next and future courses to really kind of like, and feel, confident and like know that you can do it. So it's been amazing. Okay. What should we do? Should we do more questions? I feel like everyone who's left in this lecture does not need me to draw a diagram. Who wants me to draw a diagram of what happened in the middle of the list? Oh, come on. Confidence. Confidence. You can do it. You got this. Do we want a diagram for inserting in the middle? How are we feeling? There is just like an epic... Oh, good. People do want diagrams. Oh, music to my ears. Do love a good diagram. All right. Let's draw a quick diagram. Can't speak. It's all over. I'm going to do it like on the code diagram. I'm going to go through the code and say what we're doing. Whee! Here we go. But before that, what I'm going to do is I'm going to change pen color because that blue was terrible. Let's go to red. Okay, whew, here we go. Okay, so let's say we've got a list, and let's say our list, let's actually just have a look what our list is. Here was the numbers 53110. 13510. Oh, Gary, you can add that question because Tom's in here and he can answer it. There's an assignment question. Tom, could you please answer it? Thank you. Now that you didn't know it, but it's turning into a stage 4 help session. Surprise! Okay, so let's say we have a linked list. If you didn't know, clearly drawing is another skill that I have, except for playing musical instruments. Okay, so let's say we have this beautiful list here. Okay, so then we've got, okay, so the first bit I did is to check if the list is empty. And if the list is empty, all that I'm doing is saying, okay, new node next is equal to head. All that's doing is just inserting that new node. So I've created my new node on line 189. I created a new node, and let's say I've said this is 13 and this is null. It's not linked into anything because I want to put it into the middle. I really want it to go in here. Okay, so the first thing I checked over here is whether or not the list is empty. And if the list is empty, I'm going to put it over, and I'm going to put it as the first thing in the list, basically. Okay. If the list is not empty, we're going to continue on. So the first bit here, all that it's doing is count +1, and every time it's counting how many things there are. So it's traversing the list. And so at the end of this list, the count is going to be equal to 4 once it finishes this loop. Okay, excellent. So then you go over here. All right. You've said mid is equal to count divided by 2. So that means mid is equal to 4 divided by 2, which is 2. And we've got this new variable to count up how many nodes we've gone past and how many nodes we've moved through. Okay, so what I've created here, and you can call it anything you want. I'm not sure if insert after was a terrible name. It could have been. I'm known for doing weird variable names that make sense in my head, and then when I use them I realize they don't make any sense. I would be definitely subtracted marks in the style guide. Okay, so then what I've done here is I've just basically created another current pointer. Okay, so I'm going to traverse the list, and I want to traverse the list. I want to be able to insert the thing here. So if I want to insert the thing here, I want to stop at the node before it. Okay, so insert after. I'm gonna stop at the node that I want to insert after. I've set it at 0, and now I've set it to point to here. So this is my node over here, and now I'm gonna have a look. Okay, so my while loop here is saying, okay, whilst 0 is less than mid minus 1. The reason I'm doing -1 is because if I go 2 over, what's going to happen is I'm going to end up at the third node, and I've gone too far because it's going to be hard to insert the node when I don't know what the previous one's address is. So I want to stop at the one before that I want to do the insertion point. Okay, so okay, that's why I'm going to subtract 1 from there. So I'm going to go, is 0 less than 1? Yes, it is. So I'm going to go in here and I'm going to move on to the next one. And I'm going to increase this, okay? So what that's going to do is that's going to stop me at my first node that I'm going to insert after. Okay, now that I'm sitting at this node, I am ready to start inserting, okay? So in here, I'll say new node next. So this bit here is going to be point to this node next. So that means that you're going to link those two up. And then your insert after, so this is your new, let me label them out. So this is your new node, and this is currently where my insert after is sitting. Okay, so new node next is going to be insert after next. So insert after's here, and whatever's inside here is this one. So what I've done is I'm going to point this one to here, okay? And then I'll say the insert after next. So this one next is going to be the new node. So I'm going to move this one here, which means I'm going to kill this link here. So now what I'll get is I'll get that the other node is linked in the middle of those ones. Okay, is the diagram making a little bit more sense? Sorry, Tammy, can you, does the diagram make sense? Would you like any more on any of the lines? Do any of the lines not make any sense? It's clear. Okay. All right. Okay, the next problem was... I hate this mouse. There we go. It's broken through the screen. Okay, next one was a one star problem, one dot problem, not star. I don't know where I got stars from. Let's concatenate two lists together. Okay, so it means we have two lists. We get given two lists, and we're going to join them to make one big long list. So I want to tuck on the second list onto the first one. Okay, what do you think is going to be the input and the output of that function? What do we reckon? What will be our input and output when we're concatenating two lists? Oh. How did I not? Okay. Yeah, it is. It's an easier version of it. Oh God. How did I miss that? Who knows? Oh well, there we go. Because someone asked me in the forums to do merging two lists together. Okay. Oh, it's in the tutorial questions as well. Should we move on? Should we move on to the next one, or should we concatenate? I just love the word concatenate, so. Oh, amazing. Okay. No one has any feels. It's just Friday afternoon. Everyone's done here. Okay, should we do a different one? If you've already done this one. Ah, it is 100% here. If we do this, I might feel the urge to change my 4.3 code. What do we have to pay attention to if we're concatenating? You just want the edge cases now. What do you think are the edge cases? What do you reckon? Yeah. What happens if one of those lists is empty? What happens if both of the lists are empty? What happens? Yeah. Yep, so those are things to think about. I'm going to move on because it's clearly been done before, so I'll go to the next one. Okay, count all the elements in the linked list that are divisible by a specified number. Should we do that one? What's going to give us an output and an input for this one? If we're going to count all the elements in the linked list that are divisible by a specified number. That's really annoying me that it's kind of like gone over. Output, input, what are we thinking? Yeah, an output is an int, I agree. An input would be the list. Excellent. Okay. Output is an int, and input is the head of the list, so that we know where to get it. Okay, excellent. Let's do, let's call it count divisible. If I can spell, yes I can. Always amazing. And we're giving it a struct node head. Excellent. Okay, what do we need? What are we going to do? What are we thinking? What are we feeling? What is the vibe? Okay, what are we going to do? Are we going to go through the list? What do we need to do get through the list? And this is like a one dot question. Are we going to modular? Yes, I agree. We are going to use the modulus. Agreed. That's definitely going to be our lovely Oh, yes, we do need a value. I agree. Count divisible by what? Yes, I agree. So we actually have an int value. Well done. Good pickup. We do indeed. And then we have to traverse the list. Excellent. Okay, so if we're traversing the lists, struct node current is equal to the head of the list. Okay, and then yes, sounds good. So we'll have a counter that we're going to use to count up the things that are divisible by this particular number value. Okay, excellent. And what are we going to do next? Yep, so whilst current is not equal to null to traverse our list, that means we will visit every single node. We're not going to stop. We're going to go to every single node that there is. Okay, oh great, people are already pointing out, okay, so if current number modulus value, which is this value here that was sent, so if we divide by that, it's not number, it's data. Where did I get number from? Who knows? It was in my head. I keep telling the Tom that does puns, I keep telling him to read my mind for goodness sake. But he says it switches off at 8 p.m. his ability to read my mind, which is a shame. Okay, so then we have, if that's equal to 0, that means that it divides, and then we're going to increase our counter. Well done. Okay, so someone's good. Okay, excellent. And then what are we going to do after that? Excellent. Good. So if we're finding all the elements, so we're just counting up how many there are that are divisible. We're not returning the actual numbers that are divisible. Okay, and then of course we want to be able to not create an infinite loop. So we're going to increase our current to current next and keep traversing through this list. And then at the end, we're going to return the counter. Yeah? Okay, so let's see, you know what, prototype. I'm going to remember it this time. It's going to be a rare occasion where I don't forget to do it and compile. So let's do that one. Let's pop it in here. Paste it in. Okay, and then let's ask main to use it. What should we do? Let's do printf number of items divisible by 5 is, well, I'll do by and let's do a new line. Okay, and I forgot what the function was called. Count. Yep, count divisible. We're going to give it the value 5, and we're going to give it the head pointer to start off the list. Okay, let's see if it works. The number of things divisible by 5. That's not what I meant to do. I just wanted to move it. How long will I fight with this thing for? There we go. Okay, so then the number... It's driving me insane. Okay, the 1, 3, 13, 5, 10. Yep, so the number of items divisible by 5 is 2. Fantastic. How's that? Was that easy? Easy peasy? Or was it not that easy peasy? Easy peasy? I think it was easy peasy maybe. Okay, should we now delete the first node in the linked list that's divisible by a specified number? Okay, excellent. Let's now delete. Oh, I'm going to run out of problems. I think I only did 5. Then it will be life advice the 1511 way. Okay, let's delete the first node in the linked list that is divisible by a specified number. How about that? Okay, what will be our inputs and outputs? And as soon as we're deleting, we're at 2 dots. Yep, so we're going to give it the head. We're going to get rid of the head. Yeah, so the only thing for input, because we're going to delete divisible by specified number, we also want to know what that number is. So you're right, the output is going to be the head, and the input will be whatever the value is that we want to check, and also the head. Excellent. Is there a style auto test for assignment 2? Yes, there is. Yeah. Tom, could you please type in the command in the chat? Thank you so much. Okay. Let's do it. Okay, let me do a bit of this so you can see what I'm writing. Okay, so we're returning the head, so struct node, and what should we call this function? Delete first divisible. That's a terrible name. Anyway, we're going to go with it. It's too late now. Int value and struct node head. We're giving our list, which we've said. Okay, so now let's write the actual function that will perform the magic for us. Okay, what should we consider when we're writing this sort of thing? What should we think about? Okay. So before I start traversing the list, what do I want to think about? Let's write down the boundary cases. Okay, the boundary cases are 1, empty list. Yep. 2, list with 1 node, and I want to delete that 1 node. Okay, could be a boundary depending on the context of the question, but something that's worth to think about. Okay, delete the head. Okay, what about delete the tail? And what about nothing to delete? Okay, good. Okay, so let's do the first one and check whether or not they apply to us or not. Okay, so let's do the first one. What if it is an empty list? Okay, so if head is equal to null, that means the list is empty, and I'm not going to really be deleting anything from it. I'm just going to return a null because the list is empty. Yep. Excellent. Okay, or I could return head, obviously, because the head is equal to null. Okay, next, let's do the next one. Okay, so that's this one here, empty list. We've done this one. Okay, next one. What about list with 1 node, and I want to delete that 1 node? What's going to happen then? What if the item I want to delete is in the head? Okay, what should we do? What if I have to delete the head of the list? Yep. Excellent. So if head next is equal to null, good. Let's check that. So if head, not head next, hang on. If head, so if I'm deleting whatever's inside my head data, so if head data modulus value is equal to 0, that will catch a few things. So that will catch if I'm deleting the very first thing, and then the head will change. And that will also catch the next case as well, and we'll check it. Okay, so if head data modulus the value is equal to 0, so that means it's going to be deleting, and I've got to delete. I have to delete the head. Okay, then I'm going to. What am I going to do? What are we going to do if I'm going to delete the head? It's just a quick stage. Just a quick assignment help session in here. I'm doing deleting the head now because I kept thinking about what happens if we're in the head. Okay, so yeah, so I want to free the head, but before I free the head, I really have to save what's happening inside the head. And I can't do... So everyone's saying, okay, yep, save it into a temp. Okay, let's do that. So I'm going to save struct node temp, and I'm going to whatever is sitting inside my head next, okay, because I'm about to delete the head. And then I'm going to free the head, and then I'm going to return temp. I'm trying to read the chat, but it's hard to keep up. Yeah, so we're not freeing the whole thing. We're only going to free the head because I want to only delete the first node. Okay, I want to delete the node that's divisible. So this means that the data that I need to delete the head of the list. Okay, so if I had, for example, let's do an example. If I had, let's say 3, 10, 1, delete first, that is divisible by 3. Then I want to be returning a list that says 10 and 1. So this is capturing that case, okay? Now, let's say what happens if I wanted to, let's say I've got, will it capture the case where I just say 3? What will it return then? Will it work for a case where it's going to be just a list of one thing and that's the one that I delete? So if the head is divisible, which it is, okay, I've said struct node temp is equal to head next, so that's going to be equal to null. It's going to free the head and it's going to return null. So in fact, this case here is going to work for both of the, it's going to work for both of these. It's going to do this one okay. Okay, so it's going to do this one okay. And it's also going to do this one okay. Okay. All right. What happens if we need to do we need to do anything special if we want to delete the tail? Or should we just do the normal case now and see if everything works there? Should we do that? Let's do the normal case when we actually just delete something. Let's say we've got now the example will be 3, 10, 1. Delete first thing that is divisible by 5. Okay, so that means we want to delete the 10 now. Okay, so now we want to traverse through the list, okay? Once we start traversing, traverse with your current. So I'm going to set a current to the head of the list, and then I'm going to get ready to traverse. Now, if I want to delete the 10, then where should I stop? Should I stop at the 10 to delete the 10? Or should I stop at the 3? Who remembers if we're deleting a node where we should stop? And then we'll talk about the boundary there. Oh, no more assignment 2 questions. Yep, stop before the node to delete. Excellent. So we want to stop at this node over here because we want to know where the previous node is to connect it to the one that comes after the node that we want to delete. Okay, that means what is going to be my condition in the while loop? What will I be looking for? Okay, I'm going to be moving through the list. Will I be going current? Okay, let's just go the normal thing and we'll check if it's working or not. Okay. And here I can check, okay, if current, no, that's not going to work because I'm going to stop after it. So what should I be doing to stop before it? Yep, current next, good. Okay, so current next, if current next, data, modulus value is equal to 0. Okay, now if that's equal, then I want to do some deleting, don't I? Okay, so what are we going to do with our deleting now? What do we reckon? Yay, we get to delete. Okay, so that means that we're currently standing over here and we want to connect it to this one here. So what do we reckon? What do we reckon? Okay, good. We're going to be freeing current next. Before we free it, we want to get some stuff from it. Good. Okay, we're going to delete that. I agree. And yep. So we want to hook up from our current next to current next. Yep, good. Good, okay. Okay, if I say struct node temp is equal to current next next, what that means is I've now got the address of this. Okay, so now I'm going to delete this one. And then what am I going to do next? Okay, good. And now what do I do next? Yeah. So then I'll say that the current next, which is the 3, the one that follows the 3, is going to be equal to the temp one. Okay. So we're about to have a look because we might not pick something up. Okay, excellent. Okay, and then what should we do after that? Then that's it. Okay. All right, so what's going to happen here? Okay, so someone said this should be current next is not equal to null. And why is that? And I don't disagree with this, but why is that? Why do we think that is? Okay, let's take an example of a list like this. And we'll do first thing divisible by, let's do 3, 2, 6, 5. And it will be delete first thing that is divisible by 5, okay? Now, if we delete the first thing divisible by 5, which is at the end of the list, what's going to happen is this, okay? When you're standing over here, yeah, at the 6, it's going to say current next data divided by value is equal to 0. It is. That is quite correct. And then over here, I'm going to say, okay, I want to access next. There's nothing in next. It's just equal to null. So will it work if I do this current next? What do we reckon? Will it work because I'm stopping on the previous one, or should I be changing this? What do we think? So it will look something like this. And I know I've just been writing it out instead of drawing. Please tell me if I need to draw. And I keep saying you should draw. So you should draw. Yeah. It will in this case because I'm stopping always on the one before it, okay? So it will work if I go on, if I want to delete the last thing. But we can try it as well. Should we try it? I didn't mean to do that. Oh, we haven't returned anything. Hold up. Where's the... Good gosh. Yeah, there might be an error here. I don't disagree with you. Which is one more condition that we haven't thought about, okay? Okay, so let's have a look. Yep. Yeah, so there might be. Let's have a look. Let's have a look. Or have we taken care of it because we're stopping at the previous one? Let's have a look. Let's have a look what it does for us. I forgot what the function is called again. Oh my gosh. What was it called? I don't want to scroll again. Here, delete first divisible. Thank you. What's the list? 5, 3, 1, 10. Let's delete 5 because that's going to delete the first thing for us. And let's do, well, I don't really head pointer. Okay. And then we're going to print out the list. Okay, let's do it. Should play a game. People have to do stuff when I forget to do a prototype. Especially on a Friday afternoon. Okay, let's try this again. Oh, what's going on here? Oh no, what's happening? Let's have a look. It has not liked deleting by 5. And why is that? Yeah, so why do you think this error has occurred? What do we reckon? And you would have seen, I reckon, this error quite a few times in your assignments where you're just losing the plot. Yeah, so I'm trying to access something via null pointer. Yeah, so 1, 3, 13, 5, 10. And what is happening? What do we reckon? Yeah, so that's right. So I'm trying to access a null pointer. Exactly, null data does not exist. So whenever I try to do that, that's obviously not going to work, okay? So if I'm trying to delete this one here, and I do if current next data, well, null data is not going to work for me, is it? So that's why this error is coming up in this case. Okay. Excellent. So that is something you have to look out for, okay? How do we think we can fix it? No, car next exists. It's this line here that doesn't. If I'm trying to delete something like this, okay, and I'll say current next data, this is trying to access a null data, okay, which null data does not exist. Yep, so we can stop at the one before it, okay. Okay, what happens if we do that? Will that work? Okay, so this time it deletes it. It doesn't yell at me. What happens if I wanted to delete, let's do a delete by 10. So because I want to delete the last item in the list to check. So this is what, when you're doing linked list deleting questions, check, okay? Check by deleting the tail. Okay, let's see what happens this. Will it delete the tail for me? Okay, let's compile it and run it. And of course it doesn't. Yeah, okay. That's right. Yeah, so Mark's pointed out. That's right. So now we need to take care of the deleting of the tail case. That's correct. Okay. So in this case, what will we do here? This file's gotten a bit unruly, I think. The linkedlist.c file. It's like Mad Friday vibes. Okay. So how will we take care of this tail? So when we come out of this while loop, okay, where are we sitting when we come out of our while loop? We're sitting on the last thing in the list, aren't we? Or where are we sitting? What are we doing? Where are we? What's happening? I don't know. I do know, but what's happening? Mad. It's Madhouse. We're so close to the end. 5 more minutes of concentration. Or should I leave this and we can answer it on the forum? Oh, that could be fun too. Yeah. Okay, I'm going to leave it to answer it on the forum. That will be so fun. And you have to think about it. See if you can work it out. Isn't this what you want? Homework on a Friday afternoon, last day of term? All right. Let's start to Well, it's a good one to revise things with, okay? And because then that means that you need to think of the last boundary case. And I mean, it's not like you have to do it right now. You can go chill out. You can do it next week sometime. So we've done this one. We've done that one. We haven't done this one. So think about what we shall need to do. And then there's nothing to delete, okay? Yeah. You can do it. Think about a few ways. Draw it out. All right. And I'll put an answer on the forum next week, okay? All right. I think it's time to say goodbye. You can do it on the 2nd of May. No, don't. No. I just want to say thank you, everyone, for tuning in. I know that there is not many of you left in this stream now on a Friday afternoon. A lot of you have gone off to finish their assignments. I thank you for tuning in. Thank you for making it a pretty enjoyable course to teach, and for engaging during the lecture chats. It's been really, 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 really nice. I do really appreciate the engagement that you have shown in the lectures, and I hope that you all do really, really well in the final exam. I know, everyone thinks, you're not, if you study, you will do well. If you do lots of practice problems, you will improve. Okay. But Rome wasn't built in a day. You need to do lots of practice to get better at programming. So please just do lots and lots of practice problems if you can. Come along to the revision classes as well. I hope you have a wonderful, although short break after the exam, some proper downtime. And good luck in your future courses as well. I hope to see some of you in later courses that I teach as well. It will be really, really fun. I'll just get the others to come on the camera and say bye as well, because I think everyone's feeling a little bit sad. I do teach other comp courses. Some of you, those that are doing software engineering, will see me in DESN 2000, where I will be enforcing good requirements and accessibility, which are my background actually. So there we go, UX, UI, so you'll be getting a bit of that. So I'll just get Tommy, Tammy, and the other Tommy, but who I don't call Tommy.
What?
Tom. I'll get Tom. There we go. Come say goodbye.
You go first. I'm not
Go on.
going. Oh my god.
No, there's just no one here.
Yeah, but now I have to hold on. I'll just.
Squat.
No, we're all going together.
Are you going by
Yeah, go
height?
ahead. We're all going together. Hello.
Together.
Going by height.
Oh, no, we need to put the camera.
Yeah,
up.
can we please? That's
I have to go on my
There we
tippy
go.
toe. Oh,
yeah. There we go. Nice.
Bye.
Sasha, join. Come in.
You
You can just stand in front. It'll be fine.
I
We'll
can
just
stand
do-
right in front.
Oh no, it's the wrong camera. It's the wrong camera. There
Oh,
we go.
no.
It is.
That's
Oh,
fine.
that's
Just,
funny.
there you go. Say a few words. Come on.
You're up. You're the course admin.
Come on, my course. It's true. Tommy's my course admin. He's been doing a very good job of keeping it all running.
Oh, thank you. Yeah, it's been wonderful working with you all and having you in all our classes and talking to you on the forums and that sort of stuff. As Tammy is demonstrating, we love you all very much, and we wish you the best of luck in your exams. Just remember, the exam isn't the end of the world. Everything's going to be okay.
Yeah.
Yeah, that's it.
Yeah.
That's the life. Any other life advice we should share while we're here?
As I said last time, please get degrees.
So true. So true.
Yeah. Just please enjoy these years. They are really, enjoy the social time as well. You can actually hang out now and be with other people, which is always very exciting.
I know you're going to miss your Friday nights with Sasha and the rest of us, but do try and find something else to do with your Friday nights. I'm not sure what's open on Friday. I don't know. But if you can manage to find something else to do, that might be okay.
I don't know what
Just
normally
throw
happens on
puns
Friday.
at Tom.
Yeah, exactly right.
Just come and code with the rest of us in CSE. That's what we all do, right?
Pretty much.
That's not what I do.
Oh, all right.
And if you see us in person, come up and say hi.
Please do. Yeah, absolutely.
Please do.
Yeah.
do that.
Yeah.
I've not seen anyone in person. It's
There-
been sad.
There are tutors who've met Sasha for the first time.
I
this
know.
time.
I
So
know.
that's
Like
Me.
3 days ago.
Yeah.
Yeah.
Absolutely right.
Yeah.
Cool.
So
I think everyone's been struck by just how short I am.
Yeah, you've exposed yourself a little bit here.
Yeah.
All right.
Good luck, everyone. I hope that you have a good luck. You've got this, okay? Tammy's just a giant love heart. Aw. All the feels.
Look at that.
All right. Well, good luck. Enjoy it. And oh, look at this COMP1511 meet and greet after the exam.
Yeah, challenge Sasha to a bowling match.
Do not do that. I use bumpers.
Oh no, you don't.
I'm so short.
All right, I'm gonna press the button.
All right.
Alrighty.
All right. See you guys. Good luck. Oh, I'm not even in the camera, so I'm waving to not.
Well,
No, I'm just saying goodbye. Oh no, it's this camera. Okay. Bye, everyone. Good luck.
Bye.